I presented the work equally, and then JD and Saurabh are our manager and director in Course Hero. So you have my screen, right?
Yep, we can see your screen and you're audible. Thank you. The forum is yours.
Okay. Okay, great. So in Course Hero, our platform is a proactive and assistive educational tool, and it contains practice problems, study guides, and user-submitted questions paired with answers from tutors with step-by-step explanations. And our machine learning models in our platform are designed to deeply understand students' academic questions and match them with optimal content. And also, we want to give students a unique and personalized learning journey to eventually become a proactive and assistive educational tool. So we aim to have a question type identification for our platform to identify question types from a predefined list of types like multiple choice question, shorts for MCQ, short answers, calculation, fill in the blank, and etc. So like you can see in this slide, I have a short answer question. What was the name of the characters, who, blah, blah. And also we have circuits that need some calculation. So it is labeled as calculation. So the goal of question type identifier is to decide the type of the question based on the text and also based on the structure of the question. And why do we need question type identification in our platform? There are a couple of reasons. Like, for example, we can enable students to access content seamlessly across application by enabling UI changes based on the question format. Also, we want to improve students' ability to practice by understanding their objective and matching good recommendation for them. The other reason is we route questions to tutors. So we want to improve the question routing to tutors, and also we would like to improve concept explanations by linking students with content from domain-specific knowledge resources. So there are other works, also existing works for question type identification, for improving personalization, for improved content understanding, for optimal expert selection. But to the best of our knowledge, there's no similar work to use these type of questions and use it integrated with a real world application. So my paper was actually kind of industrial paper and is practically used in our website. And regarding our method and approach, technically, we have two novelties. We use data augmentation and weak supervision for this task because labeling is always expensive and time consuming. And also we have used a multimodal architecture because we have machine learning model plus rule-based algorithm, and always the combination gives better performance. We usually have high precision for rule-based algorithm, but usually lower coverage with combination of rule-based methods with machine learning algorithm. We could achieve finally better performance, both in terms of precision and recall. So which type of questions are we looking for? We decide the question type according to the syntactic patterns, structure, and complexity. For example, we have questions that are factoid, like what is mitosis? So these type of factoid questions are categorized as short answers. And I showed here in this slide with SA. And on the other hand, if a question is subjective and open-ended, we categorize them under essay class. An example is here, like discuss the benefit and constraints of different types of network. In addition to short answer and essay, we have multiple choice question, 2 choice questions, fill in the blank, calculation, ordering. In ordering questions, it's usually asked to order something in order of something. And we have graphing, drawing, sketching. We have matching. There are usually 2 lists. We need to match them together. Ledger, usually for accounting subject. We have coding, usually for programming, computer science subjects. And also we have some structural questions that is labeled as table. We want table completion or filling forms. These are question types that we aim to design a good classifier for it. Another point about this study is that we wanted to have a multi-label classifier, meaning that a question can have assigned more than 1 label. Like this example in the right side shows a multiple choice question that needs calculation. So we assign both MCQ and calc labels to this question. So these are the introduction, and this is our architecture for the classifier. The input to the classifier is the question text. We have used BERT language model as the ML side of the classifier. And we have used the class probabilities. Like if I have 12 classes, accordingly, I have 12 logits, 12 probabilities. So I'm using those 12 probabilities in concatenation with a list of features that are extracted using regex from the text. So it's rule-based side of it. And those features are numeric features. So the combination of numeric features with the BERT probabilities fed to XGBoost classifier, which is a lightweight and fast classifier, to decide the final classes about a question text. So this is called ensemble. It's also called multimodal because we have numeric feature, and on the other hand, we have text embeddings. With this study, we found that this combined ensemble model is really good and it's working in our platform, like I said. What are the handcrafted features on the left side of this diagram? We designed 175 numeric features for those 12 classes, and like I said, using regex. We found actually some keywords that are dedicated to like a specific type of questions. Like for MCQ, multiple choice question, we usually have select all that apply. Or we usually have which of the following. So those phrases, if those phrases are existed in the question text, we count them, and those MCQ keyword count is one of 175 numeric features that we use for the rule-based part of the classifier. We also have question mark count, list count, like ABCD for MCQ, for ordering questions, for matching questions. We also have true-false questions, so list count TCQ, a two-choice question. And similarly for calculation ordering, we found some keywords that have been repeated on those type of question types more than others, like find the value of something appears in calculations more than other question types. Order something in order of something in those keywords are also appears in ordering question types. So those 175 numeric features together with the BERT are the main algorithm that is used in the question type classifier. Speaking of data set, we have used actually both public and internal data sets. For internal data sets, we manually annotated around 1,000 samples and set it aside for test set. We also trained less than 1,000 samples manually and considered it as our goal set. Then on top of those goal set, we could use weak supervision and data augmentation to have a larger data set. We called it silver set. We also had internally a data set, the third one in the list, which is called answer type. That contains 500,000 questions, but we couldn't use this data set originally for these papers because the labels are assigned according to the answers format, and also it is limited to 14 subjects, but in our platform we have over 100 academic subjects, so it couldn't cover all the subjects we wanted to have question type for. So we also used a public data set which is called TREC in this list. We use 5K samples from TREC. TREC is actually a data set of 6 semantic classes of abbreviation, entity, description, human, location, and numeric. But this definition is different from the goal of question type and the definition of question type we had in our study. But we found that all these questions are actually factoid, and we can use them under SA, short answer label. And it was good because with the rule-based, with the handcrafted feature, actually we couldn't find good number of labeling functions for a short answer. We couldn't find keywords or phrases that are for this class, but using those public data set was helpful to improve the performance of short answer questions. If I go back on augmented and the silver set, for creating the silver set, we used a snorkel technique, which is a weak supervision technique that uses labeling functions. We found those labeling functions using the manual annotation. And Snorkel actually captures the information of the labeling functions and then design a machine learning approach to create much larger training set based on the correlation of those labeling functions. So it was helpful for us to increase the size of the training set for training BERT model. We also used augmented set that was created by a similarity score between question text and the goal set we had. So we found that with the similarity of 80 to 95, we could find appropriate questions that are semantically similar to the goal set. So combination of all these data sets helps us to finish this study. Here also you can see the distribution of those 12 question types. Most of questions submitted to our platform are calculation, almost 30% of the questions. And similarly, we have essay questions and MCQs, 3 top question types that we need to manage. And the least frequent one are ordering, matching, and ledger. We did some experiment in 2 folds. First of all, we have designed an MCQ identifier. It's like a binary classifier, MCQ and non-MCQ. Then according to the promising result we had from the first experiment, we designed a flat classifier, multi-label classification of 12 labels. So for the MCQ identifier, we have tried BERT, but we found that those MCQ detection does not need such a large model. We tried distilled BERT and we got better performance. A combination of BERT or distilled BERT with XGBoost algorithm shows better recall for us. And also we have tried multimodal transformer, but the combination of our ensemble approach shows better performance. We compared the performance in terms of accuracy, F half, and weighted F score 1. So we could find 0.94 F1 score for XGBoost and distilled BERT algorithm. And also you can see precision recall curve here. So obviously our combined method, the blue diagram here shows better coverage with a 95% precision. And later, we did some error analysis for the MCQ identifier, and we found that, okay, there are some problems with some questions that the performance is not getting better than 0.94. 2 examples are here that are misclassified as non-MCQ, but they are actually MCQ. In example 1, options are 0.20, 0.4, 2, and 4. So those answer options are not clearly, obviously shown as answer options. So that's why our algorithm couldn't detect this question as MCQ. And for example 2, similarly, options are always, sometimes, never. So those 3 options was kind of misleading our algorithm to correctly classify this question as MCQ. But like I said, our MCQ identifier works pretty well with 0.95 precision and 0.62 recall on our data set, and it's actively using in our platform. Then later we thought, okay, now that we have 2 question type classification, we can have multi-label classifier with all 12 classes, which is a complicated, which is more complex problem. We found that distilled BERT does not work this time. We have used BERT, but we retune BERT with different combination of data sets. So I have snorkel generator in this table. I have BERT1 that is pre-trained with our 500,000 questions, then trained on the combination of gold set, answer type, and TREC data sets. Then we have tried BERT2 with combination of different data sets we had, and finally we found that BERT-2 works better. So combination of BERT-2 with XGBoost with those handcrafted features gave us finally 0.67 weighted F1 score and 0.71 weighted F half. I also reported F1 score for top 3 classes of question types in our platform, and the result is actually good. So for calculation, which covers almost 30% of our user questions, the F1 score is 0.84, which is acceptable. So this is all the results I have for multilabel classifier, and we found that our internal and public data set, the combination of both, was helpful in combined with using weak supervision techniques like Snorkel and data augmentation. We have found that ensembling model improves the performance of each classifiers independently. We could finally achieve F1 score of MCQ identifier for 0.94, and also for multilabel classifier 0.67, which is acceptable for our use case. And our initial A/B testing shows that using those question type identifiers is useful in improving content understanding and optimizing the routing of questions to the proper experts who can best support students in our learning platform when they get stuck. Like I said, our smart content understanding aims to enable a personalized learning engine to leverage those question types to assist the students. Like, for example, if a student is submitting MCQ, multiple choice question, or fill in the blank, or 2 choice questions, we know that students needs to better practice. If a student is submitting an essay, short answer, or calculation, you understand that students needs to better understand the critical concepts and topics. So this is all I had for today, and thank you for giving me the chance to present our study. And is there any question?